Hello class, it's Mr. Kaplan here again, and today I'll be looking at solving equations that have fractions in them. And we are going to go over the basics from the first lesson when we dealt with one-step solutions in terms of how to get rid of a fraction when we are solving for a variable. So part of that, all of that is actually going to be present in this lesson here. So remember that when you have a fraction, the way you get rid of it is to multiply both sides by whatever the denominator is. So we're actually going to see all the examples are going to be like that. So you just have to remember the basic principles, even though we are looking at questions that might be a little bit more complex than what we've seen up until this point here. So let's get straight to it over here and see how we can solve for equations that have fractions in them. So let's take a look at some examples. So when we have an equation with a fraction, the first step, or one of the main steps that we're going to see here, is that we do need to multiply both sides by the denominator. So that's how we're going to solve for that. And once you have that, you will see that you will get rid of the fraction, and then you'll be left with an equation, well, guess what? With no fractions. Now, in the event that you have two fractions that have different denominators, okay, we're actually going to look at another technique in terms of how we can get rid of a fraction using the simple technique of cross multiplication. Okay, so we're going to look at that once we see an equation that have two different denominators. So let's start off with the question dealing with only one fraction with one denominator. What we have here is 1 over 3 and brackets x plus 5 equals 7. Now, as I said before, back in the first lesson, we were dealing with one-step operations. Remember, the key goal here is to get rid of a fraction. And anytime you see a fraction, all you need to remember is you need to multiply both sides by the denominator. Now, when you do a question like this, okay, you're going to see that we're going to multiply both sides by 3 because the 3 here is the denominator. Now, when we do that, it's very important that you see the step here in terms of why we need to do that. When we multiply both sides by the denominator, which in this case here is 3, you notice that the 3's on the left side, they wind up canceling out, and guess what? We no longer have a fraction on that side. Now, a little bit of a shortcut here, you notice that there's a 1 in front of the bracket there, and remember that when you distribute a 1, a positive 1, to terms in the bracket, you basically get what's inside the brackets there. So once we do that, on the left side, we'll just get x plus 5 by itself, and then from there, we get 21. Now, you can see just by getting rid of the fraction alone, we now have a one-step solution that's going to help us answer the last part of this question. So to isolate the x, all you're going to do here is going to take the positive 5, okay? It moves to the other side and it subtracts itself from the 21. Okay, so this will give us an answer here of x equals 16. So even though there was a fraction here, you notice, again, this is a two-step solution. Okay, we got rid of the fraction by multiplying both sides by the denominator, and then from there, isolating the variable by subtracting the number from the other one. All right, let's take a look at another example. And before we do that, let's do a check here. And we're just going to do the check the exact same way that we did before, using a left side and right side check. So the left side here would be the 1/3 and brackets x plus 5, because that was on the left side of the equal sign, and the right side here is 7. So what we're going to do here is for the x, we're going to substitute that with the 16. Okay, and then 16 plus 5 will give you 21. And if you take 1/3 of 21, that will give you 7. So as you can see, the left side and the right side are exactly the same. So that's how we know our solution of 16 is indeed correct. All right, so for this next one over here, you notice that what we have here, again, it's another fraction. Now, just like we did with the previous example, you always want to get rid of the fraction first when you can. And in this case, you can do that. So the way we're going to do that is we're going to multiply both sides by the denominator, which in this case here is 4. Now, again, it's very important that you do this step and realize what happens to the two 4's on the left side when we multiply both sides by the denominator. So if you take a look at the left side there, the two 4's on the left side cancel out, and we're left over with 3 and in brackets x minus 2. And on the right side, we have 4 times 6, which gives me 24. Now, we have one additional step to take care of here, because you notice what we have here is a number 3 that's in front of the brackets. So the next thing we need to do here is to distribute the 3 to both the x and the -2. Okay, just the distribute property. So we're going to multiply the 3 to the x and the 3 to the -2, which gives us 3x minus 6 is equal to 24. Now, once we get rid of the brackets, what's remaining here is now a two-step solution. Now, remember that when you're solving for an equation, you always leave the variable term exactly where it is. You don't move it. So what do? Well, we have to take care of the stuff around it. So the first thing we need to do here is we need to take the number, which in this case here is -6. Okay, move it to the other side and then add it to the 24 that's already there. Again, anytime a number or a letter crosses the equal sign, don't forget it changes to the opposite sign. Okay, and then 24 plus 6 gives me 30. And last but not least, we now need to divide both sides by 3 because 3 is the coefficient here. And this will give us an answer here of x equals 10. So again, you can see here that as long as you know that you need to get rid of the fraction in the initial step, okay, you no longer have to deal with the fractions as you go along for the rest of the problem here. All right, now this question here and this next one, believe it or not, are the exact same thing. The only difference with this one here is how it's written. Okay, but you're going to see that even though this question here and this question here look different, the approach is exactly the same. So with that said here, notice that the denominator here is 7. So guess what? We're going to multiply both sides here by 7. Now when we do that on the left side, it's very crucial that you understand that when you multiply both sides by the denominator, the purpose of it is to cancel it out, and you can see what's remaining there. That's why I demonstrate the step where the 2 7s get crossed out, because you can see exactly what's remaining. So the next line here, what we have there remaining is the 5 and in brackets x plus 3, and then 7 times 10, that will give me 70. And from here, as you can see, just like the previous question, we're going to multiply the 5 to the x and multiply the 5 to the 3 using distributive property. So that gives me 5x plus 15 is equal to 70. Now, since we're solving for the x here, we're going to leave the term where it is. So we're going to take this positive 15, okay, move it to the other side, change it to a negative, and it subtracts itself from the 70. So 70 minus 15, that's going to give me 55. And last but not least, we're going to divide both sides by the coefficient of 5. Okay, and again, you can see much like the example where we multiplied both sides by 7. Okay, when you divide a number by its coefficient, it does the same thing. It cancels it. In this case, it cancels out the coefficient. So this will give me x is equal to 11. All right, so notice that all 3 examples so far, we got rid of the fraction first, and we no longer had any fractions to worry about. Okay, so for the next one over here, we're now going to solve equations with more than one fraction, specifically ones that have different denominators. Now, the easiest way to do this, believe it or not, is to perform cross multiplication. Now, it's very important that you can see that when we do cross multiplication for this one, okay, we are doing a multiplication of 2 terms once we do it. That's why when I demonstrate this, okay, when we see fractions on both sides of the equal sign, like I said, the easiest way to get rid of the denominator is simply just to cross multiply. Now, I want you to see that when I multiply the 4 to the other side and the 3 to the opposite side using cross multiplication, we're actually multiplying it to 2 terms. So in the next step here, I'm just going to rewrite this, and you're going to see that the 4 is going to distribute itself to the x plus 2. And the 3 is going to distribute itself to x minus 1. So what I like to do here is to actually rewrite it such that we have something that represents that. So on the left side, notice I've written down 3 and in brackets x minus 1. So we can see here that we need to multiply the 3 to both the x and the negative 1. On the right side, I'm going to take the 4 and I'm going to multiply that to the x and the 2. Okay, so you're going to see in the next step, we're going to distribute the numbers in front of the brackets respectively. And then after that, we're going to gather the like terms. So starting off with the left side here, I'm going to multiply the 3 to the x. Okay, and the 3 to the negative 1. So we get 3x minus 3 on the left side. And on the right side, we're going to distribute the 4 to the x and the 4 to the 2 by multiplication. And that will give me 4x plus 8. Now, now you can see here, we now have variables on both sides of the equal signs as well as numbers. So the easiest way to do this is to gather the letters to the left, okay, and the numbers to the right. So starting off with the letters to the left here, we're going to take this 4x, and we're going to move it to the other side of the equal sign, and it becomes a negative, and it's going to subtract itself from the 3x that's already there. Okay, and the number, -3, that's now going to move to the right side. And since it's negative, it's going to become positive and add itself to the 8. And from here, what we wind up getting here is 3x minus 4x, which is -1x, and an 8 plus 3, which is 11. Now, in the final step here, remember that what we want to do here is to solve for x, so we're not quite done yet. So for the grand finale here, we're going to now divide both sides here by -1. And that's going to give us a final answer here of -11. Okay, so remember that anytime you see letters on both sides of the equal sign, the easiest way to gather the terms is put the letters to the left of the equal sign and the numbers to the right of the equal sign. And then from there, simplify and solve using gathering like terms. Okay, so let's take a look at another one here. Again, exact same thing. So what we have here is 1 over 5 in brackets x minus 3 equals 1 over 6 and x plus 4 here. Now, what I'm going to do first here, just to show you that when you have a fraction where the numerator is 1 and you're not comfortable with working with something with those fractions in front, you can simply just rewrite it by taking the bracket and rewriting it all over the denominator, which you can see I've done here. We haven't even done any math yet. Okay, and again, this is just to simplify the fact that when we cross multiply, we won't need to worry about the ones. So let's do that. So what we're going to do here, we're going to cross multiply the 5 to both the x and the 4. And we're going to cross multiply the 6 to both the x and the -3. Okay, so on the left side, I have 6 and in brackets x minus 3. Okay, and on the right side, we have 5 and in brackets x plus 4. Now, the next step here, we're now going to distribute the x's. So starting off with the 6, we're going to multiply to the x and the -3. That gives me 6x minus 18. And on the right side, we have 5 times x and 5 times 4, which gives me 5x plus 20. Now, the good thing about this one over here, again, if you take a look at the x's, we have x's on both sides of the equal sign as well as numbers. So again, we want the variables to the left, starting off with the 5x. So we're going to take the 5x, move to the other side, and subtract it from the 6x that's already there. Okay, in a similar fashion, we're now going to take the -18. Okay, it's going to go to the other side, and we're going to add it to the 20 that's already there. So for the final answer here, believe it or not, our next step will give us the final answer, because remember when you have, well, 6x minus 5x is going to give us 1x, which is just x on its own. So in the next step, guess what? We get the answer, x equals 38. So you can see here, when you have two fractions with different denominators, the easiest way to get rid of the fractions is to cross multiply. All right, this one over here, I just changed it a bit just to change the order of the x's here, but the technique is exactly the same. So anytime you see two fractions with two different denominators, again, the easiest way to get rid of it is to cross multiply. So when you do that, we're going to multiply the 5 to both the 5 and the -2x, and the 4 to both the 6 and the -x. Okay, so I'm just rewriting this step over here so you can see, as a reminder, that we do need to multiply those numbers to the two terms on the cross side there. So starting off with the 5, we're going to multiply the 5 to the 5, and the 5 to the -2x, which gives me 25 minus 10x. And you're going to multiply the 4 to the x and the 4 to the -x, which gives me 24 minus 4x. Now, just like all the questions we've seen where we had variables on both sides of the equal sign as well as numbers, okay, we're going to keep it nice and simple by taking all the letters and moving them to the left, and the numbers and moving them to the right. So starting off with this -4x here, since it's on the right side, we're going to move to the other side, and it becomes addition, and we're going to add that to the -10x that's already there. Now the 25, since it's positive when it goes to the other side, we're going to subtract it from the 24 that's already there. So -10x plus 4x gives me -6x, 24 minus 25 gives me -1. Now for this one over here, you're going to see that when we divide both sides here by -6, okay, we wind up with a fraction. Okay, now when you're solving equations, unless you're prompted to do so, never express your answer as a decimal. So the final answer to this, as you can see, when you have two negatives, it becomes a positive. The final answer will just simply be x equals 1 over 6. All right. Now, again, anytime you're solving for equations, again, unless you're prompted to do so, please make sure that you express your answers as a fraction in lowest terms. Okay, and in a question like this, okay, never leave it as never express it as a decimal. Okay, if you went 1 divided by 6, you'll wind up getting repeating numbers, and we don't really want that. All right. Okay, so next thing we're going to do, we're just going to look at a word problem here so we can see how it's how we can actually use a geometric formula, specifically the area of a trapezoid, which happens to have a fraction in it, and how we can use that to solve a problem for an unknown dimension. So Kumiko is designing a rock garden in the shape of a trapezoid, as you can see in the top right-hand corner there. And what we want to do here is to solve for the unknown dimension, which is designated by the lowercase b here. So what we know here is that she decides that the garden should have a front width of 8 meters and depth of 5 meters. The area must be 50 meters squared to fit her design. So the formula that we're going to use here is area is equal to a plus b in brackets h over 2. Now what we're going to do for this one is to use this formula, okay, and replace all the variables that have numbers and see what we have missing. So starting off with the a over here, we have an a 50 meters squared, so that's going to go in for the capital A. We have a lowercase a here to be 8, so that goes in for the A. And as you can see, I'm highlighting what I'm replacing here. Next one here, we're going to take that 5 there, and that's going to go in for the H. So everything that I've highlighted there in different colors is going to be replaced with those numbers. So in our next step, we get something that looks like this. Now, there are a couple things that you could do in the next step here. However, the easiest thing that we can do here is to get rid of the fraction. Now remember, anytime you see a fractions, always stick to the basics that we saw when we were dealing with solving using one-step solutions, that anytime you see a fraction, all you have to do is to multiply both sides by the denominator. Now, this next part over here is very important to understand, that when we multiply both sides by the denominator, okay, the 2 2's on the right side cancel out. Okay, and don't forget, you're multiplying the 50 by 2 as well. So on the left side, 2 times 50 is 100. But on the right side, notice what we have here is the 2 2's cancel out. And what's left over there will be the 8 plus b in brackets and the 5 on the outside. Now recall when we were dealing with the distributive property, okay, and when you see a number that's outside of the brackets, okay, you treat it exactly the same as you would any type with a typical distributive property question. So on the right side here, I'm going to distribute the 8 to the 5, okay, and the b to the 5. Okay, now if you decide to distribute the 5 to the 8 and the b, you will get the exact same answer. So what we wind up getting here is 8 times 5 is 40, and then b times 5 is 5b. Now again, just as a reminder that anytime you multiply a number to a variable, the number always goes in front of the variable. Now, it's not too often that we see a variable on the right side here, but this is a good example to do here, because I want you to see it doesn't matter what side the variable is, as long as it's the only variable, you leave it exactly where it is. So you're probably asking, well, how in the world are we going to isolate this variable if the variable happens to be on the right side? Again, stick to the basics. Anytime you see a variable by itself, you always leave it where it is. So that 5b is going to stay on the right side. So what we need to take care of is the 40, which happens to be also on the right side. Now, since we want to keep the b on the right side, because you want to keep variables on one side and numbers on the opposite side, we're going to take this 40. It's going to go to to the left side this time, but the same rules apply. Anytime a number or a letter goes to the opposite side of the equal sign, it always changes to the opposite sign. So when this 40 goes to the other side, it becomes negative and then subtracts itself from the 100. So what we have here will be 100 minus 40, which gives me 60. And last but not least here, we need to isolate the variable. Now remember that when you isolate the variable and you notice the number and the letter are attached together, okay, what you have to do here is to divide both sides by the coefficient. Okay, now again, just as a reminder, the coefficient is the number that's attached to the variable. So the final step over here, we're going to divide both sides here by 5, okay, to cancel out the 5's on the right side here. Okay, so again, typically we see the letter on the left side, but this is just to show you, again, basic principles that anytime you isolate a variable and there's a number attached to it, you always divide both sides by whatever is attached to that variable. And last but not least, 60 divided by 5, that gives me 12, okay, which in this case here would be 12 meters. All right. Okay, so that wraps up this lesson here. So you can continue on working on the questions, and I'll see you in the next lesson.